Section 7.6, Solving Rational Inequalities. You're going to learn in this section how to solve rational inequalities. You're going to solve an inequality with rational functions. Here is a warm-up activity we're going to do. You will be doing that with the prerequisites. So make sure you finish your prerequisites before you begin learning about this topic. So the first expression here is 7 over x minus 4 minus 3 over x. We would like to try to simplify that expression. So we're going to find the least common denominator. The least common denominator is basically a denominator that is divisible by all of the other denominators. So what we have here is we have the x and then we have x minus 4 and we can leave it like that. So now that is our least common denominator. So we're going to rewrite our rational expressions here. So we have 7 over x minus 4. So what we have this part of the least common denominator. We will need the other part. So the other part is going to be the x. We're going to multiply x in the denominator, and we have to do the same in the numerator. So we're not affecting this expression. Minus 3 over x. So that is what we have. What we're missing is this part of the least common denominator. So we're going to multiply both numerator and denominator by x minus 4. And now we basically can simplify that expression. So I will leave a space here and I will try to simplify it. And then I'll try to simplify. So the first one is going to be 7x. And then we have the same denominator, so we're going to keep it over the same denominator, minus 3 times x minus 4. And then we can simplify the numerator. We can have 7x. We're going to distribute the negative 3 inside. So we're going to have negative 3x minus times minus is positive, so positive 12 over x times x minus 4. So this simplifies to 7x minus 3x is 4x plus 12 over x times x minus 4. And if we want to make it look a little bit nicer, we can say we pull the 4 out. So we'll have x plus 3 over x times x minus 4. And that is the simplest form, basically. So the idea of this warm-up is to practice the least common denominator. Now we have an equation 7 over x minus 4 equals 3 and we want to solve. So the first step that you're going to do is to remove the denominator, and because we have a variable in the denominator in this case, we must remove the denominator. In order to get rid of the denominator, you're going to multiply both sides of the equation with the denominator or the least common denominator. In this case, it is the denominator itself. So we're going to multiply x minus 4 times 7 over x minus 4, and I'll put parentheses here, equals 3 times x minus 4. So here is the least common denominator I used to multiply. Just the 3 here, just the 4 minus x minus 4 here. So now we have these cancels together, and we have 7 equals 3 times x minus 4. We have to distribute the 3 inside. So we have 7 equals 3x minus 12. We solve this. So we add 12 to both sides. 19 equals 3x, and then divide both sides by 3. We get x equals 19 over 3. So as you can see here, when we solve an equation, the result is going to be just one solution. We know that is the answer for an equation. But when we solve an inequality, the solution is not going to be just one answer, because the result is going to look something like this. X is greater than 3, for example, or x is less than 3. We know that there are many solutions in this case. It's just not one solution. My suggestion is we graph the result to better help us show all of the solutions. So if we want to graph this solution on an open number line or just on a number line, you're going to highlight the direction of this inequality. So you're going to highlight all of the x's that are greater than 3, and the 3 is not included. And I also would recommend to include an open circle if the 3 is not included. If it's included, then make it into a closed circle to indicate that it is included in the solution. To represent that in an interval notation, we know to start from left to right. So the interval starts from 3, and it does not have an end, which means it goes to positive infinity. And the 3 is excluded, so we represent that with parentheses. And the infinity is going to have parentheses as well, because we do not know what infinity is. In order to solve a rational inequality, we first write the inequality with only one quotient on the left and 0 on the right. That has to be the case. So if there is anything on the right, we have to remove it and make it into 0. The next step is to determine the critical points to use to divide the number line into intervals. And then a critical point is basically a number which make the rational expression 0 or undefined. So we're going to look for these numbers. I will show you how to do that. And then we're going to evaluate the factors of the numerator and the denominator and find the quotient in each interval. This will identify the interval or intervals that contains all of the solutions of the rational inequality. It sounds more complicated than it is, so I will show you with the steps, and it's going to probably make sense. And then we're going to write the solution in an interval notation, being careful to determine whether the endpoints are included or excluded. So in order to do that, let's look at this example right here. This example, we have to solve x minus 1 over x plus 3 is greater than or equal to 0. As you can see, this is already written with one quotient on the left and the 0 on the right, so we do not have to worry about making the right-hand side 0. Next, we're going to find the critical points. Again, the critical points are any points that make the expression equal to 0 or undefined. In this case, what makes the expression undefined is if the denominator is equal to 0. So how do we find the critical points? We're going to set x plus 3. Let's make it equal to 0 and then solve. So you will get minus 3 minus 3. You will get x is equal to negative 3. That is our first critical point. Okay, critical point. The next critical point is what makes the expression 0. That is any x that makes the numerator 0. So we're going to say x minus 1 equals to 0. And then we're going to solve this equation. So we're going to add 1 to both sides. We get x equals positive 1. So that is our second critical point. The next step is to identify these critical points on an open number line and divide the open number line into 3 intervals in this case as such. So we have the negative 3 is here, and to indicate that this is not included because it comes from the denominator, so if we include that, it's just going to make the expression undefined. So anything that comes from the denominator is excluded from our solutions. It has to be open. So that's why we put a dashed line here. Okay. And then the other critical point, which comes from the numerator, is the 1, and the 1 is basically included. So now we're going to pick testing points. So a testing point is basically a point that happens to be in the interval, and if you plug it back into the inequality, it's going to satisfy the inequality or makes it true if that interval is the solution. If it's not, then it's not going to make it true. So we're going to pick, let's say, negative 4 from this interval as a testing point. I will pick 0 here because it's easy. I will pick 2 because it's the smallest. Now we're going to test the sign of the inequality with these testing points. So if I test it, if I plug negative 4, for example, in each of these intervals, so this is included, we said, so I'm going to put a solid line here. So if we test, we basically replace the x in the inequality with the testing point. So if I do that, I will get negative 4 minus 1 over negative 4 plus 3. So I'm not going to look for the final answer. I will just look for the signs. So the numerator is negative and the denominator is negative. Negative over negative is positive, which means this interval is going to be positive. If I test to 0, I'm going to erase this. I will say 0 minus 1 over 0 plus 3. The numerator is negative, the denominator is positive, so this is negative. So it is negative. Different signs give negative, similar signs give positive. Last one, I'm going to plug the 2. 2 minus 1 over 2 plus 3. What I'm doing is replacing the x in this inequality. So the numerator clearly is a positive, the denominator is a positive, so the whole interval is going to be positive. Now, our inequality says it's greater than 0, which means it's positive. So this interval and that interval are both in the solution. How do we interpret the solution, or how do we write it as an interval notation? So as you can see here, we read it from left to right. This interval right here starts from negative infinity, always open from the side of negative infinity or positive infinity. It goes all the way to negative 3 and stops, and the negative 3 is excluded, so we represent that with parentheses. And that is basically the first part of the solution. The second part is this interval right here, which basically starts from 2, and the 2 is included, so we're going to put a bracket there. Sorry, it starts from 1. And the 1 is included, so we're going to put a bracket there, and it goes all the way to positive infinity. We put the parentheses there because we don't know what the infinity is, which is the other side of the solution. And the final thing is to include a union in between them. So that is the union sign in between them. And that is how basically you're going to solve these rational inequalities. So hopefully the steps now made sense. Again, few points. Any critical point that comes from the denominator is always excluded. Anything that comes from the numerator depends on the sign. If it has an equal sign, it is included. If it doesn't, then it is excluded. In this case, it is included, and you can tell because there is an equal sign. But the denominator is always excluded because the point that comes from the denominator makes the expression undefined. So we cannot use that for a solution. Here is another example. Solve for x over x minus 6 less than 1. First, we need to subtract the 1 because the right-hand side must be equal to 0. So the skills that we practice today is going to come handy. We need to use the least common denominator to combine the left-hand side together. So first we subtract 1, which is done in this step right here. Now we need a common denominator, or the least common denominator. The least common denominator is basically a denominator that divides all of the denominator, or the denominators go evenly into it. So in this case, we only have x minus 6, so that is going to be the least common denominator. So now we rewrite everything with the new denominator. So we have 4x over x minus 6, that is the first part. And then the 1, we need to keep the 1 minus 1 over x minus 6. So what we did to the 1, we multiplied x minus 6 in the numerator. In the denominator, we're going to do the same in the numerator. We're going to do the same in the numerator, less than 0. Now we're going to combine. Don't forget to distribute the negative sign inside. So we will have 4x minus x plus 6 over x minus 6 is less than 0. That is the step missing here. And now we combine. 4x minus x is 3x, which is this one, plus 6 over x minus 6. Now we get the critical points. So we first make the numerator equal to 0. We have 3x plus 6 equals to 0, minus 6 minus 6. We get 3x equals negative 6 divided by 3. We get x equals negative 2. And we have to say if it's included or excluded. In this case, it came from the numerator, so it can be included or excluded depending on the sign. The sign does not have an equal, so this is excluded. And then the one that comes from the denominator is always excluded. So we make the denominator equal to 0. Add 6, we get x equals to 6, and that is the other critical point, which is excluded. because it came from the denominator. So now we're going to put these 2 points on a number line and then indicate inclusiveness or exclusiveness, okay? We have the -2. The -2 is excluded, so we're going to put a dashed line here. Same with the 6, it's excluded, so we're going to put a dashed line here. Next, we're going to pick testing points. From the first interval, we picked -3. From the second interval, we picked 0. Be careful with these. Sometimes you will make the mistake of picking the number that doesn't actually exist in that interval, and that is a very common one. And then 7, we're going to pick it from the third interval. Next, we're going to test these testing points. So we plug them back into our last expression, this expression right here. We don't use the first one. We use the last expression. So if you plug them in, again, don't worry about the numbers. You can basically worry about the signs only. So clearly the numerator for the first one is negative. The denominator is negative. So negative over negative becomes positive, which means the first interval here is positive. The second one, if you plug 0, you will get positive over negative, which is basically negative. Positive over negative is negative, so this interval is going to be negative. The last interval, we try 7. We end up with positive over positive, which is going to give us positive, which means the last interval is positive. Now, the last inequality here says less than 0, which means we're looking for the negatives. So the solution is going to be the negative interval. And now we represent it in an interval notation. It starts from -2 to 6, and the -2 is excluded, and the 6 is excluded. We can see the solutions from the 2 previous questions graphically, actually. So if you graph the inequality on a software, let's say Desmos.com, you will see the parts where the first inequality is greater than 0. So it's anything above the x-axis, which is basically this area right here and this area. So the area between the function and the x-axis is basically the solution. If you notice, the solution is from here, which is from 1 to positive infinity, and it is from negative infinity to 3. You can tell that graphically. Similar with the second one. So for the second one, we're going to look at the last inequality and graph it on Desmos, this one. And as you can see, it is less than 0. So we ended up with 3x plus 6 over x minus 6 is less than 0. If you graph that, you will notice that the solution is basically the area below the x-axis, and that area is just this area right here. We don't have any other area between the graph and the x-axis except for this that is below the x-axis. Anything else is above, so it's not a solution. So you can see clearly here that the solution is from this point, which is -2 all the way to 6, and excluded both of them because the inequality sign is does not have an equal, and you notice that this line is dashed. Usually it doesn't show up on some of the softwares, but if you do it on Desmos, it might show up as dashed. So that is how you can tell by graphing these inequalities. You can tell the solution of the inequalities. That concludes section 7.6. I hope this was helpful. If you have any questions, let me know.